In the previous video, we have taught you how to install the LED lights in 3 layers. This time, we will teach you how to program it to illuminate outward, from the inside towards the outside. When programming an Arduino Uno microcontroller, you use a USB to connect the microcontroller to the computer. But when you're running it already with those illuminated lights, you use a battery up to 12 volts. You cannot use any amount of battery higher than 12 volts because that would destroy the microcontroller. If you are new to this channel, just hit the subscribe button for free. First, we will set up the microcontroller for the input and output pins to be used. The brightness should be initially 0. And then you write anything else outside the setup loop so that it will not be part of the setup. We assign pin number 3 for the innermost pin. And we assign it as an output. We do the same for the middle pin to be assigned to pin number 5, and it will also be an output. For the outermost pin, we set pins 6 and 9 as they are alternating sets of LED lights to illuminate. Take note that the pins we have selected for the outputs have pulse width modulation so that they can be illuminated gradually from 0 to 255 in an analog manner. We program the inner lights to illuminate in 1 second gradually. To be able to do that, we assign the pin number 3 as the source of the positive terminal and ground as the negative one. Remember that DC or direct current flows in one direction along the LED lights. We use a for loop to program the gradual illumination of the inner lights. Take note we didn't go up to 255 because the 60 LED lights have a maximum rating of 4.5 volts. And the microcontroller would normally give each pin up to 5 volts. This is just to protect the LED lights from getting overvolted, from receiving too much voltage. And then, speaking about the number 230 for the maximum analog brightness, we assign a delay of 4 milliseconds so that the entire loop for the inner lights would last about 1 second. Next, we illuminate the middle lights for the same amount of time. We connect the LED lights in a similar manner to the inner one for these middle lights, except that we use pin number 5 as the source of the positive terminal and the same ground for the negative one. This time, we select the brightness to a maximum of 153 only, as it is just a 3-volt source of LED lights. We didn't go up to 255 as that would damage the LED lights. Speaking about the number 153, we select the delay time of 6 milliseconds so that the repeated execution of the for loop would total an amount of 1 second. The middle pin will be assigned with a maximum brightness of 153 only. The outer lights will be illuminated in 2 seconds. This USB connected source of 5 volts has 2 sets of outer lights. To be able to illuminate both at the same time, we have to alternately illuminate these 2 sets very quickly with just a few milliseconds to spare to switch from one set to the other. Since this is a 5-volt source, it's alright to put the brightness to a maximum of 255. For the first part of the for loop, we select the first set of outer pin to be illuminated, then delay it with 4 milliseconds, and then we illuminate the other outer pin, the other set of lights, and delay it again with the same amount of time, 4 milliseconds. For each loop, there is a total delay of 8 milliseconds. And then you multiply that with the number 255, the total cycle, the total process time of illuminating these outer lights would be around 2 seconds. We will maintain the illumination of the entire snowflake for 16 seconds. Those are all the wiring diagram that are connected to the LED lights. The total delay time for each execution of the for loop is 4 milliseconds. Therefore, we have to repeat this 4,000 times to give a total of 16,000 milliseconds, or simply 16 seconds. We will now preview the frozen snowflake as a whole set. The yellow lights that are being highlighted in the specific line of program indicates which part of the loop is it executing. Isn't that amazing how you can program a frozen snowflake using an Arduino Uno microcontroller?